Lower solar activity reveals red auroras, more than the blue-green that we usually see. This is the latest on space weather. All quiet, solar activity very low as the solar cycle continues its dip into the nadir of a deep solar minimum. There's not even a solar wind stream on the horizon. The next significant gust of solar wind is not expected for at least a week, so we have to stay tuned for that. Even though we have quiet activity, low solar activity reveals red auroras. For the past 2 nights, geomagnetic activity has been very low, with no sunspots, no solar flares, and no significant streams of solar wind to disrupt our planet's magnetic field. The forecast called for no auroras, yet auroras are appearing anyway, and they were crazy reds, reported by Marcus Varick of Norway. We have them in Germany, we have them all along the northern hemisphere. Red auroras, which is very strange. Usually they're more greenish blue. On Saturday night, Abisko got all red. Sunday was our turn, says Varick. It was great to see these rare red auroras from our own backyard. Now, where did the red come from? The answer, ironically, may be due to the low solar activity. Varick's backyard is located beneath Earth's persistent auroral oval, a gentle rain of solar wind electrons guided to Earth by our planet's curved magnetic field, creating a polar ring of northern lights that intersects the latitudes of Troms, and which is the area where Varick got the images from. Now, the thing about the auroral oval, it's green on the bottom and red on top. Green is the color of molecular oxygen, and red is the color of atomic oxygen. When the auroral oval contracts during periods of low solar activity, residents of Toms can see over the top, and that is, they'd see red. These electrons cooked up something really nice, said Varick. No sunspots required. Now, having to do with how many sunspot number, total update of November 4th, 2019, 70 days without sunspots. That's 19% of the days. Cosmic rays, solar minimum is underway, and the sun's magnetic field is weak, allowing extra cosmic rays into the solar system. Neutron counts from the University of Oulu's Sodankya Geophysical Observatory show that cosmic rays reaching Earth in 2019 are near a space-age peak. Today we had a plus 9.3% high. The 7-day change was minus 5.5%. Maximum is plus 11.7%. That's very high. So today we have a 9.3% high. We had 22 fireballs November 3rd. Every night, a network of NASA all-sky cameras scans the skies above the United States for meteoric fireballs. Automated software maintained by NASA's Meteoroid Environment Office calculates their orbits, velocity, penetration depth in Earth's atmosphere, and many other characteristics. Daily results are presented on space weather. Near-Earth asteroids, as of November 4th, 2018 potentially hazardous asteroids. The next one would be today. It's only 0.5 lunar distances from Earth. It's about 12 kilometers per second velocity, and diameter is about 40 feet wide. The next one is November 7th at 3.8 lunar distances at 30 feet wide. The next one after that is November 8th at 1.3 lunar distances, about 120 feet wide. After that is November 11th, 3.1 lunar distances of about 100 feet wide. And November 13, 3.8 lunar distances, about 141 meters, about 400 feet wide. That's pretty big. Now, the cosmic rays in the atmosphere, they're constantly flying radiation sensors on board airplanes over the U.S. and around the world, and so far collected more than 22,000 GPS-tagged radiation measurements, and using this unique data set, they can predict the dosage on any flight over the US with an error no worse than 15%. It's ERAD, the Empirical Radiation Model, ERAD for short. Every day they monitor about 1,400 flights crisscrossing the 10 busiest routes in continental USA. This includes more than 80,000 passengers a day, and ERAD calculates the radiation exposure for every single flight. To measure the radiation on the airplanes, they use same sensors that were flown in the stratosphere on board Earth-to-Sky calculus cosmic ray balloons, the neutron bubble chambers and X-ray, gamma-ray Geiger tubes, sensitive to energies between 10 keV and 20 MeV, energy spanning the range of medical X-ray machines and airport security scanners. Now, about once a week, space weather balloon data from spaceweather.com. Students of Earth-to-Sky calculus fly space weather balloons into the stratosphere over California, and they are equipped with radiation sensors to detect cosmic rays. It's a down-to-earth form of space weather. The cosmic rays are dangerous. They can seed clouds, trigger lightning, and penetrate commercial airplanes. Also, there are studies linking cosmic rays with cardiac arrhythmias and sudden cardiac death in the general population. The latest measurements show that cosmic rays are intensifying with an increase of more than 18% since 2015. The data points to the peak of the Renninger-Pfalzer maximum, which lies about 67,000 feet above central California. When cosmic rays crash into the Earth's atmosphere, they produce a spray of secondary particles that's most intense at the entrance to the atmosphere. Now, en route to the stratosphere, the sensors also pass through aviation altitudes. And the dose rates are expressed as multiples of sea level. For instance, we see that boarding a plane that flies at 25,000 feet exposes passengers to dose rates of 10 times higher than sea level. But if you go up to 40,000 feet, the multiplier is close to 50 times higher than sea level. Radiation sensors on board helium balloons detect X-rays and gamma rays in the range of 10 keV to 20 MeVs. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.